Hey everybody, welcome to video 15-2. We're going to start here on page 794, and in this section we are talking about inscribed quadrilaterals. So as you know from our last section, that word inscribed means that the angles are formed by chords. Well, this is true in inscribed quadrilateral. It just means all four sides of the quadrilateral are chords, and therefore all four angles are inscribed angles. There's a theorem that you need to know about the angles in an inscribed quadrilateral, and that is here. The inscribed quadrilateral theorem says that if a quadrilateral is inscribed in a circle, and we're going to discover that not all quadrilaterals can be inscribed inside of a circle, but some can, and if that is happening, then its opposite angles are supplementary. So angle A and C here would add up to 180, and angle B and D here in the diagram would add up to 180. So we're just going to do a quick little proof to show you why that is. So we're given that the quadrilateral is inscribed in the circle, and what we are being asked to prove here is that A and C are supplementary and B and D are supplementary. So the first thing we're going to know here is that this word union just means add the two together. So if I go from arc B to C to D, and also arc D through A to B, that essentially takes up my whole circle. It's circle O. Therefore, the measures, when you add them together, is the full 360 degrees for a circle. Since A is an inscribed angle here in step 2, and its intercepted arc is arc BCD, then angle A, and also angle C is an inscribed angle which has an intercepted arc for DAB, then because of the inscribed angle theorem I know from the last section, I know that the measure of angle A is going to be just half of the measure of the arc it cuts off, which is BCD. And the measure of angle C will also be half of the arc it cuts off, which is DAB. So if I put those two pieces together, and I want to figure out what the sum of those angles is, then in my first box I have half the measure of arc BCD plus half the measure of arc DAB to put those two angles together. Then you can see what's coming next. We're going to take the 1/2s out from the front of each of those expressions, and when we use the distributive property, kind of backwards a little bit, we're going to say that the measure of the arc BCD plus the measure of the arc DAB in parentheses, so we know we're going to do that addition together first, and we know what those arcs are supposed to add up to because that's the full circle. So half of the full circle's measure of 360 is going to be 180 degrees, and that proves that A and C are supplementary by the definition of supplementary, which means they add up to 180 degrees. And you can also do the same type of proof when you show the opposite angles B and D being supplementary. So that's just a quick little proof of why this theorem is the way that it is. And just a quick note as we move to the top of 795, you just need to keep in mind that the converse is also true of this theorem, which means that instead of knowing that it's inscribed and therefore the angles are supplementary, we reverse the logic and we talk about that if the angles are supplementary, then it's a quadrilateral that has the potential to be inscribed in a circle. Since those directions are both true, just kind of keep that in mind here. So next we're going to move on to explain 2, which is just using this theorem and doing some algebra and kind of finding some missing pieces here. It says find the angle measures of each inscribed quadrilateral is the instructions. When it says angle measures, it means all of the angle measures, okay? So for part A, we're going to find the value of y, and we're going to start by putting together some opposite angles. So you can see that P and R are opposite angles, and we know they're supposed to add up to 180. So we're going to take what P is equal to, 5y plus 3, and what R is equal to, 15y plus 17, and we're going to do some algebra. We get 20y plus 20 equals 180. Subtracting 20, we would have 20y equals 60, and then solving for y, we get y equals 8. Now that we know what y is, we can go ahead and put that into each angle. So P is going to be 5 times what we just found for y, which is 8, plus 3, which is 43. R, we can go ahead and substitute in, or we can do a quick subtraction since we know that it's supplementary for these two numbers, but we get 137. Then we're going to find our missing angle Q. We're going to substitute in the 8, so 8 squared plus 53 gives us 117. And notice we have no label for angle S, but we do know that angle S and angle Q are opposite angles in that diagram, and therefore they're supplementary. So it's got to add up to the 117 that I know plus the S that I don't know has to add up to 180. Do a quick subtraction there, and we get 63. If we go on to the next page, on page 796, we have a new example here that we can fill in. So we're going to again find all the measures of the angles in this diagram. We have this time J, K, L, M. Also, keep in mind it might help to do a little bracket that J and L go together and K and M go together. We're just skipping a vertex in each of the diagrams to think about the opposite angles. Remember when we did that with quadrilaterals. So first we're going to take the J and the L as opposite angles, and we know that they add up to 180. So substitute in what we know those algebraic labels are, which is 39 plus 7x plus 6x minus 15 is going to equal 180. Then we're going to add up our common like terms there. 13x plus 24 is equal to 180. Okay, subtracting 24 from both sides, we get 13x equals 156. And then dividing both sides by 13, we get x equals 12. So we need to substitute that in every time we have a variable that needs it. And so we're going to substitute in 12 for J and L's expressions, and we get 123 and 57, which hopefully you can see as a supplementary pairing there. Going to do the same thing and substitute the value we just found into measure angle K. So that's 20 times 12 over 3, or 240 over 3, or 80. And then we know that the measure of M and K together have to equal 180. So even though we don't have a label here on measure of angle M as far as an algebraic label, we can just do a subtraction of the 80 we just found from 180. And we know that the measure of angle M equals 100. And so with our final line here, we have the measure of angle J is 123. The measure of angle L is 57. The measure of angle K is 80. And the measure of angle M is 100. You have a your turn problem coming up here next. So it's same exact idea using the inscribed quadrilateral theorem. And make sure you do that before you go on to explain 3. On the next page, explain 3 just talks about the steps for constructing an inscribed square. So a square inside of a circle, the steps there. Steps 1, 2, and 3 are the construction steps. And I just want you to make a note to keep these in mind for evaluate problem number 9, which you're going to have in your work tomorrow, okay? But those are the steps, and the steps are the following. Draw the circle in step 1, mark the center O, and then draw a diameter just through that center. Then once you have the diameter drawn, you're going to construct the perpendicular bisector of the diameter. That's our gut the fish, remember? And you're going to label the points where the bisector intersects the circle as C and D. So here's the picture. Here's my initial diagram, and then here is my bisector that goes through it, which is essentially creating another diameter for you. Then once you have those diameters, which you know are perpendicular, you're going to connect all four corners. And that's constructing a square inside of a circle. And again, we're not going to go through the proof here. We're not going to go through the steps in an example, but just make note that these three steps, that these three steps are needed for tomorrow's work. And then the final thing I'll just point out to you is we're not going to do the your turn this time. We're actually doing the elaborate question. So as we look at elaborate number 8 here, this is a situation where you're critiquing the reasoning. So the homework problem, this Marcus person thinks that he has some missing information from his diagram. You need to critique his work and see whether he's right and why he's saying that it's not a doable problem, and see if that work has been done correctly or not, and then kind of think through how that problem could be thought through, okay? The homework problem that you're given is find the measures of the angles of quadrilateral ABCD, which can be inscribed in a circle. So there's the diagram there, and there's his work. See if they jive together with what you know about inscribed quadrilaterals. You don't have to write a book here. I know there's a lot of lines. They don't all need to be filled in, but just kind of get some thought process down, and we'll check that tomorrow. All right, we'll see you next time.